Awesome. Good afternoon, everyone. My name's Kelly, and I've been working in security for just about a year now, but before that, my background is mostly in data engineering, data science, and that kind of stuff. And so I have a lot of experience working with tools like Apache Spark. Is anybody here familiar with Spark at all? All right, we got a couple of hands. Well, you're in the right place because this talk is going to provide an introduction to what that tool is. And we're also going to spend a lot of time looking at password data, which is going to be pretty fun. So I started using Spark. It's in the 2.x versions now, but started using it in about 2015 when it was running maybe like 1.0, and that was at an ad tech company where we were analyzing terabytes of data a day. That wasn't for any security purposes, but that was for log normalization, counting, all those fun things that you do when you work in ad tech to keep the internet free. I work at Twilio now, and since moving there, I work more with security and identity and authentication, and so this talk is going to combine all of those things using the data engineering experience to look at some password data, because passwords are terrifying and fun to look at. So there is going to be some code in this presentation, but if you're not a programmer, that's cool, because one of the great things about Apache Spark is that it provides a lot of interfaces for working with data that you don't need to know Python or Scala or any of these crazy languages for. So we're going to be looking at a lot of this doing just raw SQL. So my name is Kelly Robinson. I live out in San Francisco, but I'm actually from Michigan. So my parents, thank you for giving me an excuse to visit home. I'm super stoked to be here. This is the closest that I'll ever get to like a hometown security conference. So thank you for having me at my first GrrCON. I work at Twilio, like I mentioned. For those of you that aren't familiar, Twilio is a communications company, so we build APIs for things like sending and receiving text messages, making and receiving voice calls, and also things for authentication. I work on our authentication products. Twilio actually acquired Authy back in 2015, and so I work on the Authy team there. Doing a lot of stuff with our APIs for multi-factor authentication, phone verification, phone intelligence, fun stuff like that. And so that's why I spend a lot of my days now thinking about securing online identities, looking at passwords and why they're terrible, and all that good stuff. So we're going to talk a little bit about what Spark is, how it's progressed over the years. I'm going to give a little bit of background into the state of passwords, and then I'm going to give a demo of how Spark works, and that's when we're going to dive into the password data. And then I'm going to close out just talking about some of the implications at the intersection of big data and security. So let's start by talking about Apache Spark. So at log management solutions, what do you guys use? Like Splunk, we're cloud-based? Shout it out. Elk, yeah. So Spark can be run. It's a data platform that can be run on top of your Elasticsearch. It can be run on top of S3. It can be run on top of any kind of data storage that you use it to do either batch or stream processing for doing data normalization and analytics. And so it markets itself as a fast, unified analytics engine for big data and machine learning. It provides a functional interface for working with the data, and it has interfaces and APIs for doing that in languages like Scala, Python, SQL, and R. It's generally thought of as an improvement on top of Hadoop and MapReduce. In fact, it was built on top of Hadoop and MapReduce, but it's about 100 times faster than that. So people really like moving to Spark because it saves them a lot of time and therefore money and compute costs. When my company moved from Hadoop, we at least decreased our compute bills by about 3x because of the overhead that we were spending before to run these Hadoop jobs for like 24 hours. We were able to move to a more streaming model, which also got results out faster to our interested parties, and therefore people were more happy, which also for using this as a tool for things like security incident response or log detection or any kind of anomaly detection like that, Spark is a really good tool for that kind of stuff because you can do this in a micro batching environment. So when I talk about big data, I'm talking about things that don't fit on a single machine. Everything that I'm going to show you today, for the sake of demoing, I'm doing off of my local machine. So you can do everything that I'm going to show you with like a Python script. But Spark really is powerful in the way that you can use it to do things at small scale and really large scale. So if you can get it running on a small amount of data, it scales really easily when you grow that data, 1000x. So I just want to point that out because a lot of times people talk about big data and they don't actually have big data. In an audience like this, if you're doing a lot of log collection for your security and audit purposes, you probably do have data if your company is at all sizable. But in a lot of like the development audiences, people are like, yeah, I've got like 100 gigabytes on the, a month that I collect. And I'm like, you're fine. Put that on a single machine. Amazon has resources for that now. So one of the biggest benefits of Spark is that it comes with all of these APIs out of the box. It comes with support for multiple languages and extensions. And Spark also has built-in libraries for doing things like I mentioned, like streaming data and machine learning, really touting the machine learning aspect of things these days. If you were in the keynote this morning, we talked about that a little bit, about like machine learning and what does that mean. Usually it's a lot of times people are just crunching numbers. I think if anybody has had experience working with data scientists, or if your team does any kind of machine learning, a lot of times that is code for data analytics. I might be a little jaded about this point. You can come rant with me after if you feel similarly. But it's not always implementing mathematical models. It's a lot of times looking for patterns in the data, and you can do that by using some brute force techniques. As my friend Ryan likes to say, machine learning is really like the carrot that you dangle in front of engineers to get them to do the data engineering work. And so it's a really good thing that you can use to entice people to get your data in a format that makes sense for you to work with and for you to query. So there are two major abstractions with Spark. They started out with this idea of RDDs, or resilient distributed data sets, and those aren't going away, but in later versions of the framework, it's moved more towards data frames. And these both have their benefits and different costs and risks associated with them, but in general, people are encouraging you to move more towards data frames these days, mostly because working with data frames is faster. But we're going to talk a little bit about RDDs. So these work with immutable and distributed collections, and they have functional operations on top of them. And so if anybody has done any functional programming, Spark was originally built on top of the Scala programming language, which is, I have other opinions about, but it is a functional style language. And so a lot of the operations on top of that are functional in nature. And you can see how that's used in the code example here for doing a basic map reduce, for doing a word count. RDDs aren't going away, like I mentioned. They still have their uses for working with any kind of unstructured data because they give you that low-level control for looking at every single record and doing operations on them at that unstructured level. But the biggest problem was that RDDs were slow, especially if you were using any language besides Scala. And so there were some traps that you could fall into that wouldn't produce optimized code. And this was stuff that was not obvious if you weren't either benchmarking your code or very familiar with how the project worked. And so the team was aware of this, and they developed the data frame API on top of that. And data frames are very similar to something like data frames in Python, pandas, that kind of stuff. And the API works with structured or semi-structured data, and you can either do schema inference or provide it a schema. And because of that and the structure that you get with a schema, you get a lot of optimizations that Spark does for you under the hood to index the data and make it really fast to query it on the other side. And so we're going to be looking at the untyped API because I'm going to be doing most of my code examples in SQL and Python, but just know that they also have a strongly typed API if you're working with a language like Java or Scala. Like I mentioned, one of the big disadvantages early on is that RDDs were just so much slower, but you can see that with the data frame API, no matter what language you're working with, it's just as fast across the board. And so this was really good for the community because there's a really good community of data-minded engineering in the Python community and the R community. But a lot of those people were having to learn Scala in order to get some performance gains in their code. And a lot of people like that. You don't want to have to learn Scala and introduce a new language into your stack just to get some performance improvements. And so I'm really glad that Spark introduced the speed ups in the 2.x version for data frames and improving the speed there. Like I said, I come from a Scala background, and even I don't think that people should have to learn Scala to use this tool. But that's kind of an introduction to the state of Apache Spark and where it's come from. I want to take a little bit of time talking about the state of passwords, but first we must appreciate what is the glorious of hacker stock photos on the internet. I actually paid money for this because I thought it was that good. You know this guy's good because, like, on top of all the encrypted garbage, he got hacked to show up on the screen because we all know how realistic that is. I love this guy. So we have a lot of problems when it comes to passwords, right? So we have password reuse, which is really common, and people use that for credential stuffing. And so this is why we have an entire industry built around multi-factor authentication and all these other fun things that people are trying to use to help secure online identities. And so you might hope that nobody does this and nobody sets their password to 1, 2, 3, 4, 5, 6, but of course people do. So this password, 123456, has been seen over 22 million times. This, according to the website Have I Been Owned from Troy Hunt. How many people are familiar with this website? For those of you that aren't, this is a website that you can go to, enter your email address, see what data breaches your email address has been seen in. This is all data that's available on the internet, but what Troy Hunt did, he's a security researcher based out of Australia. He like rides a jet ski to work. Weird dude, but cool dude. So he basically aggregated all this information in a very useful way so that end users like us or your parents or your siblings can go online and get information about where they have their data or their credentials have been seen in a data breach. And he does this for emails and passwords. And he actually just released a new API that allows you to look up whether your password has been seen in a data breach without actually giving the API your password, which is pretty cool. So the way he does that is you do a basic SHA-1 hash of your password, send him the first 5 digits of the hash. He'll send you back a list. The API sends you back a list of all of the passwords that match that prefix. And then you take that list and see if the suffix for your hash is in the return. And if it's there, then that means you can see the number of times that your password has been seen in a breach. And so this is really cool because it also provides a way, if you're really paranoid about just typing in your password to a website, you can look at that and see if your password, if it's a secure password that you're using for your email or something like that, has been seen in a breach. And so not only does he provide the website for doing this and the interface for doing that, but he also makes this data available for download. And there's tons of data breach downloads available across the internet. I like this one because it's easy to use and it provides some information already aggregated about the number of times that emails have been seen. So this is the data that we're going to be using to show off Apache Spark. So I'm going to switch over. And we're going to be doing a little bit of live code here. And so this tool that I'm using right now is called Zeppelin. Zeppelin is kind of like a Jupyter notebook, but it has a built-in Python interpreter. I already wrote out the import statements because I always forget those. And so the first thing that we're going to be doing to show off Apache Spark is just importing the data that we have. And so this is data that I have stored on my local machine. And so we can go ahead and read that in. It's in the folder that had, and so I'm going to grab all of the CSV files from there and then just go ahead and print out the schema for this data. And so this is pretty cool because print schema is a built-in Spark function that will allow you to show you the shape of your data because Spark does schema inference and it also does built-in CSV, JSON, Parquet, and a couple of other text format file reads that you don't have to write your own interpreters for, which is pretty cool. And so the other thing that you can do with this is like, we're not getting a lot of useful information about the schema types here, and so I want to, I happen to know that these CSV files have a header, and so I want to go ahead and import that. And once I do that, we get the header names that are there, and this is something else that Spark will read in for us so that we don't have to define that. But the one thing that I also want to add to this is that this is interpreting all those file fields as strings, and I happen to know that count's an integer, and so I'm going to ahead and tell it to infer the types of the data fields so that we can use that for sorting. And now you see that the count has an integer type there, and so we can use this to sort our data on. And then one of the things that's cool about Spark is that it also has a SQL-like DSL that we can use on this, and so I'm not going to do anything with that hash column, and so I'm just going to go ahead and select the columns that I care about, which is the password column and the count column. And then once we have that, we can go ahead and do an order by like you would in SQL, and we'll go ahead and order by that count column because we did declare it as an integer. And then we're going to go ahead and do a descending. The Python API makes you say ascending is false. And then you can go ahead and show this data. And so this is going to show us the top passwords that are seen in Troy Hunt's data breach files. And so this is exactly what you would expect. And so you have 1, 2, 3, 4, 5, 6, QWERTY, I love you, that's nice. It gets more interesting as you go down, monkey, dragon, but that's Game of Thrones influence there. So you can start to see the types of passwords that people come up with. Of course, these are all terrible. If any of these are your passwords for sites that you care about, please go change them. I won't be offended if you walk out of this talk. So this is some information about the passwords that you have. Very basic query that you can do with Spark. We're running at about 680,000 records here. I truncated the data size so that it would run for the sake of demos. But again, if you had terabytes of data, you could run the same exact operations on this using the same code. Spark evaluates all of that lazily, and so it doesn't actually do any of the computation until you do something that forces it to display the data like a show. And even then, if you're not doing any kind of sorting operation on the data, it'll just sample the data so that you don't have to do all of the operations and the transformations on all of the data. So that's cool, but I want to look at something else. So we can look at the most common lengths of passwords. And so we can do this by adding a column. And so I'm going to add the length column using the built-in length function. And so this is going to be doing a transformation on this. And then once we have that information, well, let's just see what that looks like. And so you can see that the length column is computed there and adds up as a new column. But one of the things that I want to do with this is basically create a view for it so that we can run raw SQL queries on this. And so this is what this view is going to do. We'll give it a name. And so once we have that, you see that I've been running this with PySpark interpreters. If I change that to SQL interpreters, now I can write raw SQL to get data information back about this that you might otherwise need to write some custom code for, which is really useful for a tool like this if you have people that might not know code, but they know SQL, which is a programming language, but some people don't know Python and they might know SQL. And so we'll do that, select from our passwords table, and then order by and group by our length. And one of the things that I really like about this tool, Zeppelin, is that it comes with some of these built-in data visualizations. And so I don't know who uses pie charts for this kind of stuff, but you can see all this stuff is like stuff that I didn't have to do out of the box. And so I think it's really cool that you can build these charts and stuff like this so that you can hand this off and have a report that you hand off to an executive or somebody that you might want to show some visualizations to, that you get this all for free out of the box, which is really cool. So one of the other things that's cool about this is you can do all of the where statements. So if you do like where password, if you do like grr, so you can do all the filters there. But then you can also do dynamic filters using this. And so if you do this, then you'll get this password field that you can do, and then you can say like, if you want to change that to Python, you want to change that to Kelley. There's a lot of people that use my name and passwords, how flattering. But if you then you can get rid of that. And so this becomes a dynamic form that you can use to hand off to people and show them some interesting stuff. So most common lengths of passwords, nothing too surprising here, 6 and 8 characters. Those are common password minimum length requirements. And so obviously that's what a lot of users end up setting as their minimum passwords because they don't want to have to remember more characters than they need to. So that's pretty interesting. But that was using a built-in function to add that column. If you want to create your own function, you can too. And so we'll write a suffix function to try to get some information about like numeric suffixes. And so we can do that using a little bit of regex, test my regex on the fly here. So we want to see anything that's not a or like a letter in our suffix, and then we can go ahead and filter by anything that's not a letter, match the string there, and then if there's a match, we'll go ahead and return just the suffix part of that. And so we can return the string, and then we'll just do a little bit of string slicing here. And so that's going to get the index that we first saw the match at, and then take everything after that. If we don't have that, then we'll just return an empty string saying that there was no suffix. If we want to, that's not the right comment. So then if we want to add this column, we can go ahead and do that. I don't think this is going to work out of the box, but I'll show you what will work and the error message that you'll get here when this fails. And so we also want to feed it the password column. And so this is going to throw us an error saying an expected a string or buffer because suffix is not taking in the actual column type. And the way that we do that is we actually turn this into a user-defined function. And so PySpark has or PySQL has a built-in way to do that. And so we can say, you know, our suffix UDF, and then we'll just wrap that function in that UDF function. And then if we change this, then we can go ahead and show that data. And so now we have that suffix available for us that gives us some information there that then we can use that to query. And so you're starting to transform the data that you have in some really creative ways. And if you know just a little bit of Python, you can do that really dynamically. One thing that I want to do is I want to get rid of like all numeric things. And so I'm just going to change this match here to see if the start position is after 0. So if I do that, then it gets rid of these all numeric ones, and it just leaves me with the numeric suffixes. This isn't a perfect function, but it'll give us what we need for now. So I'll go ahead and create or replace that table, and then we can write some more code here to look at some of the most common suffixes, which I think is pretty cool. So we can go ahead and group by those. In the same way that we did for getting the most common lengths. And then we'll order by the most common counts so that we can get an idea of what the most common suffixes are. So you can see it's probably nothing too surprising there. People add numbers to their passwords. They add numbers that are very obvious. Let's go ahead and filter out anything that's not empty there. So that'll get rid of the empty one there. So you can see that there's like, you know, 100 million people that just add the letter or the number 1 to the end of their passwords. And so this is one of the reasons that like password policies that are like, hey, your password must contain both a letter and a number are terrible because people just do this shit. Like, and they also replace letters with numbers in the way that are very predictable. So you get things like, you know, P4, $, like, you know, we've all done that at one point because we thought it was a good idea and a website made us do that, but it's, you know, we're not that creative. We all have the same idea for like letter to number substitutions, and so it ends up being the same stuff that we see over and over again, and so passwords that you might think are secure actually aren't. One other thing that you can do with this is you can chain these transformations together, and so if you want to look at like suffixes that are all 4 characters long, you can chain that, and so you can use the length of your suffix column. And so then when you do that, you can also say if the suffix length is 4, and then you can look at all the 4-character suffixes. And again, this is an interesting experiment because it shows you how common this like 4-character suffixes or numeric suffixes are, 1, 2, 3, 4, and then it's years from like the last like 30 or 40 years, which is either like the year somebody was born or the year that they graduated from high school and that kind of stuff. And so these are all, you know, if you're doing any kind of brute force technology on trying to crack passwords or pins, it's something like 80% of 4-digit pins are the year that somebody was born, and so it really narrows the attack surface for doing that kind of brute forcing because people aren't that creative and they want to use something that they can remember. And so I think that's pretty interesting. I'm going to hop back over to the presentation so that I can finish that up. But I hope that gives you an idea of like how Apache Spark works and some of the stuff that you can do with it. I think it's a really cool tool. Obviously, it has some major benefits. I don't know if anybody here has spent time working with a tool like Hadoop, but once you start working with Spark, and especially if you had any experience moving from RDDs to data frames, it's so pleasant to be able to write code in a way that makes sense in a data analytics form. And especially if you have analysts on your team that have experience writing SQL, it's a really powerful tool to share across different functions of the team. And any tool like Spark that's going to be able to combine the functionality of data engineering and data science and put that under the same roof and make those teams able to more closely work together is going to have a lot of benefits for the rest of your all right, we lost one of the screens, but we're back. So that's going to have a lot of benefits for your team in order to make sure that your team can work together cohesively, because obviously these all come down to working together as a team. Security is always a people problem, right? So like I mentioned, fast, flexible, and this is really proven for large systems. I was using this a lot just for doing data analysis and sampling. Even if you don't want to do large scale systems, ETLs, that kind of stuff with Spark, you can still use it to kind of dig into your data, do some sampling. It has built-in functionality for doing that as well. Of course, Spark is not without challenges. Some of the error messages are pretty opaque. I don't know if you picked up on any of that. Operationalizing this, getting it from your single machine to a cluster can be challenging if you've never done it before. There are some good tutorials out there for that now, but the project is still pretty new. It's only been available for about 3 years, and in GA for, it's been in GA for about 3 years, around for maybe 5. But there are really large companies that are using this. There are companies that are dedicated to working on the project. There's an entire SaaS product around working with Spark so that you can use this at scale, and they have a dedicated investment into making sure that the project continues to be developed. And I think a lot of the path that they're taking with this stuff is more along the data frame side of thing, instead of investing in the original spec, which is more around like the Scala-centric functional programming side of stuff. This is an example of an error message I got once when I was trying to do a descending column. So one of the things that you'll notice is if you're writing Python code, you'll actually get nested Java stack traces, which is really fun. Except that it's not. So you'll see that there's like Java stack traces, and that's because the interpreter under the hood is all run on the JVM, and so this can be really nasty to debug if you're not familiar with debugging Java stack traces. There was a great talk at PyCon earlier this year that I have linked to at the end of these slides. If that's something that you're going to be dealing with, I highly recommend that you check that out. All right, finally, I wanted to take some time to talk about the things that we can learn from working with big data and security. I think that's something that a lot of people in this room probably spend a lot of time doing. This graphic sums up a lot of what we saw with the password data. If you try to guide your users towards a secure password using only character requirements, you're probably not going to end up with very secure passwords. Unfortunately, NIST, the National Institute of Standards and Technology, I think I got that acronym right, it didn't update its password policies until like 2016, and it finally just got rid of that, saying that you have to have a special character in your password to make it more secure. Because in the last 15 years, we found out that that doesn't actually help make passwords more secure. But unfortunately, most websites existed before 2016 and wrote their authentication systems before 2016, and therefore most authentication systems still make these requirements. And so that's one thing that you can do to make your login processes a little bit more secure, is get rid of those requirements. It certainly doesn't help. And there's other things that you can do to help guide your users to make them more secure, and I'll talk a little bit more about that. So we see shit like this all the time. This was from like 2 weeks ago, if anybody else saw this article. This is really, really common, and one of the things that I think is interesting for us right now, especially on the authentication side of things, is that on the bright side, security is on everyone's mind right now. So we have all these data breaches that are happening, especially with things like Equifax and like things like GDPR, like data privacy and trust and security. Like, people are thinking about this now, which makes our jobs a little bit easier to sell our products or convince management that we need to invest in this kind of stuff, because I think it's a little bit easier to say like, hey, you might not think that we're going to be breached, but like, look at all these other people that are having this problem, and we could be next. But especially, we can't separate security from development now. And I spend a lot of my time talking to developers and trying to encourage them to think about, secure practices in their development. And really, like, all developers are security engineers now. We just have to get them in that mindset. And that's going to take some time for us to do. But I think that as security professionals, we have the power to do that. And it turns out that developers are generally pretty jazzed thinking about security things. So it's a good practice to have, and to enable them and equip them with that knowledge makes them more excited to keep their code secure. Because nobody's security is perfect. So if you have any influence over security at your company, especially is anybody here like not technically on a security team? You're just like interested in security? Yeah, we got a couple. And so like, people like you especially, like you might not have security in your job title, but like you are a good champion for the organization because you have the power to be like, listen, like I'm not even technically getting paid to do this, I just think this is important for these reasons. And you can start to build awareness and a following amongst your peers at work to start thinking about that too. And there's a lot of things that you can do that don't require budget, that don't require, getting management buy-in even at first, that you can start to do to just change that mindset, whether that's through like code reviews, whether that's through just thinking about like tech talk, security culture. One thing that I used to do at my last company was like the easiest professional development thing that you can do is you can like once a month get together at lunch and watch a YouTube video together. Like you don't have to make anybody prepare for a talk. You just say, hey, we're all going to sit here and like watch Chris's talk from earlier today. Like we all missed that at GrrCON 2017, so like we're gonna watch that next Friday. And that's something really easy you can do to start like building excitement around these things, learning together and that kind of stuff. So this tweet, if you haven't seen it, was from when it was revealed that T-Mobile Austria, this was before T-Mobile parent company revealed that they had been breached. But they were storing plain text passwords, and unfortunately the security or the customer service agent like really doubled down on the impossibility of that being a problem. So don't be like T-Mobile Austria. Could happen to anyone, and as long as we start to think about the best practices that we have, I think we'll be on our way to making things more secure. It's also up to us to find ways to improve user experience while we keep things secure. So it's completely forgivable, in my opinion, that users have bad passwords. If you were just in Jason's talk, I think he was talking about putting a lot of the onus on users, but I think he was usually talking about employees when he was talking about users. If you're using any kind of like end user authentication system, especially if those users are customers that you don't have like under the control of your IT department, it's totally forgivable if they have bad passwords, and there's definitely things that you can do to encourage them to have stronger passwords. Length is one of those ways. Longer passwords are harder to brute force. One-time passwords are an option. This is how you sign into Lyft. If you log out on your phone, Lyft, it's the attack surface there. Maybe it's just my account that I'm not a super high risk score there, but one-time passwords can make sense where they are applicable to your threat model and your security for your company. Passwords aren't great. I think a lot of people are coming around to that idea, but they're also not going to go away anytime soon. We're starting to get into this idea of like using multi-factor authentication as a passwordless authentication, using biometrics, but you don't want to just trust any company to start using your fingerprint as your ID, because then if that gets breached, then you're going to have a bad time all over. So even that's not a perfect solution, right? Because like SMS has all of its own kind of vulnerabilities, and I'll rant about that for way too long if you let me. I do want to point out that it's the onus of developers and on the company to have the responsibility to secure authentication. And I really emphasize developers here because I do want to avoid victim blaming. It's really easy to tell people to just use a password manager. I've done it, but like how many people here use a password manager? Who doesn't use a password manager? All right, who has like one password that they use for everything? Who has like one password that, yeah, thank you, one person's being honest. Who has a password that they use for like their email and another password for everything else? Like password for your bank account and your email and then another password for everything else? Yeah. So like, we're a security room, and there's even people here that are admitting to like using, just a few passwords, but password reuse is really common because we're human. We only have so much memory in our brains, and there are ways that we can get around this that don't involve necessarily using password managers or going that extreme. My dad uses a password protected Excel spreadsheet, and I'm like, go Ron. That is so cool, because honestly, he's like covering his bases. He can give my mom the password if she needs to get into any of that stuff. And it's not quite as heavyweight as using a password manager, but that's a system that works for him, and that's going to be more secure than the alternative of using the same password for everything. You can get into crazy ideas for this kind of stuff too. As long as your email password is secure, you can type in gibberish for every other password that you have and reset it every time you log into those websites. That's an option. Like, it depends on how secure you want to be, how easy you want it to be to get into those websites every time that you need to log in. There are options available for this. as the end user. But as developers, we have a responsibility to make it easier for users to have secure passwords and to prevent them from using passwords that might harm them. And so adding reasonable password requirements to your site is one way to do that. Follow the updated NIST standards for that. But also you can use this own passwords data to start to prevent users from using common passwords. And so GitHub just started doing this, and several other websites have as well, where they downloaded the same data dump that I was showing you earlier. And then every time the user sets their password, you do this client side before you store it, before you hash it and salt it. And so you do this client side and you look it up against the common passwords and you say, hey, you know, you're trying to set your password to 1, 2, 3, 4, 5, 6. We're not going to let you do that, and here's why. GitHub is a developer-focused interface. It's aimed at people that can click the read more about this, and will probably get that. This isn't going to work for every website. grandmasflowers.com probably doesn't want to implement this, but you get the idea. You understand your audience, and if this is something that might make sense for you, this is going to be, it's a good way to show that like you're on top of security things, and it's a good way to show that you're hip. I just used the word hip, which means I'm not hip. But it's a good way to like add some password security without making the user do anything, because we want to make it easy for the user to not fail. And finally, just aim for a seamless user experience. I think, you know, we're always thinking about security on these axes of like how secure and how usable we want it to be. But there are ways that you can do this using, this is like push authentication, which we all know and love now, for adding MFA to your user experience. And 2FA and MFA help make this problem of credential stuffing like a little less bad, because then even if your credentials get hacked, you still have an area of defense. So if you do want to rant about any of this, I highly recommend this Twitter account. It's basically just retweets bad password policies. Here's one from earlier this week from Delta. So you can't use like the less than symbol. So think about that if you want to go hack Delta. I did not just suggest that you do that. So check this out if you want to rant about things. If you want to read more about this, there are APIs or there's language SDKs in about every language that you want. To wrap the own passwords API. So there's a post about that. The middle one is a blog post that I wrote about just a tutorial for how to do what I showed you today. And finally, Troy Hunt on the right has a post about where other companies like GitHub are using this in the real world, if you want to get some more inspiration. The slides are already posted on my Twitter. It's my Twitter up there if you want to go check that out. Hopefully this talk has given you some more insight into both the state of passwords and some of the tools that you can use to look into that kind of data. I think this is my like spirit stock photo, so this is what I like to close with. I think Apache Spark is a great tool to do a lot of very powerful analysis, and now you have an idea of where to get started and what you can do with it. Come find me after this if you have any questions or just want to rant about password policies. Once again, my name is Kelley Robinson, and thank you for listening.